Good morning everyone. I am Ms.K.K.D.Bhavani, working as Assistant Professor in Triple Department from Swarnandhra College of Engineering and Technology. Today I am going to present a small topic from power electronics, buck and boost converters. So, coming to my presentation flow consists of what is a DC to DC converter, buck converter, boost converter and its conclusion. So coming to the topic, what is a DC to DC converter? So mainly what we can say that what is a converter? So converter is a device which converts one form of energy level into another form. So it is called as converter. So coming to DC to DC converter, so DC to DC converter is a device, electromechanical device, or it is an electronic circuit which converts mainly fixed voltage level to variable voltage level. So in this diagram it is clearly shown that, so here what we considered fixed DC input means the voltage is constant. After passing this voltage through this converter, what is the output? So it is as variable DC output, which means that, so something like on and off, so irregular. So it is termed as DC to DC converter. So in DC to DC converter we have two modes, that is buck converter and boost converter. So in this slide we are going to present step down chopper or buck converter. So converter, chopper, so both are similar but there is a small difference. What is that means? Converter is a device which converts one form to another form. Like in DC to DC converter we can say that it converts fixed DC to variable DC. But so the difference between this converter and this chopper is, so buck converter means it definitely consists of filter at the end in the circuit, but chopper it won't. So that's the difference between a chopper and conductor. So coming to this definition, step down chopper, which means that the output voltage of the circuit is always less than the input voltage. That's why it is termed as step down chopper. So the basic circuit diagram is shown below. So here plus minus, so input is taken from this side. So this is the input voltage Vs. Next, chopper is connected in this position. So CH, this chopper acts like switch. Next, a diode is connected in between these two terminals, a freewheeling diode. Next, in this one inductor is connected across the load. This is the basic circuit diagram for step down chopper. So in this we have two modes of operation. When CH is on state, second one chopper is in off state. So we have two modes of operation here. So coming to that, so firstly we will see when chopper is in on state. So chopper is in on state. What happened means, so when we pass this supply Vs, it flows through this. The switch is, when we pass this supply means the switch is in closed state. So current is passing through this circuit. Next, current will pass through this and through this. Next, whenever this supply pass, here negative terminal is there. So negative terminal means this freewheeling diode is in off state, which means that like this, it will become off state. Next, the total current will flow through this inductor, later on it goes through the load. From this we can say that what is the path of voltage? Here Vs is there, Vs passes through this line and comes across the load. So Vs is equal to directly V0. So supply voltage is equal to V0. During which operation? Chopper is in on state. Output voltage is Vs is equal to V0. So this is on state operation. So now consider when the chopper is in off state. which means that the switch is in off position. When the switch is in off position means even if you pass the supply, it won't go through this network because it is in off state. Now what happens? During on position, the inductor will charge. So whatever the charge is going on in operation, it will discharge in off state. So inductor changes its polarity and the freewheeling diode will be forward biased, and whatever the energy stored in the inductor will goes to the load, which means that the supply voltage will never goes to the load. From this we can say that during off state Vs is V naught is equal to 0. So during on state only the chopper becomes on state. During off position the output voltage will 0. This is shown in figure. So this is the waveform. Here different values are we have taken. So the first one is Vs means supply Vs means supply voltage, source voltage, or we can say that. Here IL is inductor current. Next V0 is output voltage. Next Is is source current. Next ID is diode current. So in this waveform the total operation will be shown like that. See, input voltage means supply. Here we take it as constant DC voltage. So the waveform will be in straight line. Next, inductor. As we know that during on state, T on, T off. So total when we consider one cycle, this is T. Whenever the inductor is in on state, that time period is called as T on. Whenever the inductor is in off, whenever the chopper is in off state, that is called as T off. The total time period is T. So during on state, the inductor is charges. That's why the current rises from minimum to maximum. Later, from T on to T off, the inductor discharge. So the same cycle repeats for another period. Next, during on state only, here we can clearly say that voltage will be present during on state in step down converter. Next, during T off, the voltage will be 0. Next, source current. Whenever voltage goes to the load, then only source current will be present. Whenever the switch is in off state, the source current will be 0. Next, as we know that freewheeling diode conducts only in off state. That's why diode current will be present in off state only. So these are the waveforms regarding buck converter.